Hello friends, Mr. Burrell here. We're in the middle of Unit 6. We've been talking about exponents, and we've started with kind of reviewing some rules that you've probably heard before associated with exponential expressions, the product rule, the quotient rule. Then we talked about negative exponents and zero exponents. We've talked about some different things that happen when we're simplifying exponential expressions. Today, we're going to talk about changing forms between exponential expressions and radical functions. Exponential and radical functions. So we've talked about radicals back in Unit 5. We talked about like square roots and cube roots. In this unit, we've been talking about exponential expressions. Today, we're going to talk about how they're related, how they're similar, and how they're different. But before we get there, I want to introduce something. I want to have you think about something just for a second, because I've had questions like this in the past. So here's the thought: why is anything to the 0 power equal to 1? So like, for example, 2 to the 0 power or x to the 0 power. We talked about in the last lesson how anything to the 0 power is equal to 1. If I have 1,234 to the 0 power is equal to 1. Why is that the case? I have lots of students that ask me, well, why isn't it 0? Why isn't anything to the 0 power 0? Well, take a look at this for a second. So I've told you that anything to the 0 power is 1. We've tested it out a couple times in our calculator, but riddle me this. What if I have like x to the 3rd power divided by x to the 3rd power? What about that? What's x to the 3rd divided by x to the 3rd? Well, I could write each of those out as x times x times x over x times x times x. X divided by x just cancels to make 1. X divided by x just cancels to make 1. X divided by x just cancels to make 1. So x cubed over x cubed is 1. Anything divided by itself is 1, right? Okay. Well, if I take what I kind of deduced, what I've kind of learned in that first lesson when we were talking about multiplying and dividing exponents, we talked about when I have the quotient rule says when I have two bases with exponents, if I'm dividing those bases, then I subtract the exponents, which would be x cubed over x cubed. If I take 3 minus 3, that gives me x to the 0. Well, I just showed that x to the 3rd over x to the 3rd is equal to 1, and I also showed that x to the 3rd over x to the 3rd is the same as writing x to the 0. So, x to the 0 and 1 are the exact same thing. X to the 0 power is equal to 1. Put any number in there for x that you want to, almost any single number that you want to, and that's going to be equal to 1. Anything to the 0 power is equal to 1. So that's kind of a way to think about that. If you've struggled with that in the past, that's kind of a way to visually see that. So, in this lesson, now getting on to what we actually want to talk about today, we're going to talk about switching back and forth between radical and exponent form. And we're going to review simplifying radicals using prime factorization. So again, we've talked about radicals in Unit 5. We talked about square roots. We talked about cube roots. And we talked about how there's other kinds of roots. Like I could have like a radical with an index of 4, a 4th root, or a 5th root, or whatever. You know, I can have whatever I want. But today we're going to talk about the similarities and differences between radicals and exponents and how I can kind of relate the two. So, in case you didn't get it from context, remind yourself what a radical is. When I say radical, what do I mean? Well, when I say radical, I'm talking about these things. This symbol right here is a radical symbol. I often call this a square root. I often call this a cube root. When there's nothing here, there's really like an invisible 2. It means it's a square root. This one means it's a cube root. Okay, so you might remember, like, back when we were talking about radicals, I talked about number prison. If I was trying to simplify this radical, I broke 45 down into its prime factors. 9 times 5, 3 times 3. I put all my factors underneath my radical here, underneath my prison, and they had to escape in pairs. 2 3s, 2 x's, 1 3 dies, 1 x dies. So this 3 and the x get out, and they multiply. This 5 and the x stay in, and they multiply. So I could write the square root of 45x to the 3rd as 3x times the square root of 5x. The same principle applied with the cube root, except instead of in groups of 2, they had to escape in groups of 3. Okay, not 13, 3. So that's what a radical is. We talked about that last unit. So now, kind of relating that to what we've been talking about with exponents, it can often come in handy to switch between exponent and radical form in order to make problems easier to solve. So I'm going to give you some problems in radical form. I'm going to give you some problems in exponential form. Sometimes one may be easier to solve than the other. So if I have something written in exponent form like this, x to the a over b power, I can translate that and write it in radical form like this. The radical with b as the index and a as the exponent. Okay, so notice if I have something written with a fraction exponent here, the bottom becomes the index, the top becomes the exponent. The root goes in the ground, the exponent goes in the sky. That's kind of a way that I like to remember it. The root goes in the ground, the exponent goes in the sky. Top, bottom, sky, root. Okay? So for example, if I had the square root of 2, I can write that as 2 to the 1/2. Or the square root of 2 to the 1st. The root goes in the bottom, the power goes in the sky. Okay, so the square root of 2 can be written as 2 to the 1/2. The cube root of 2 can be written as 2 to the 1/3 power. So this radical, the cube root, I can write as 2 to the 1/3 power. The cube root of x to the 4th, the root goes in the ground, the power goes in the sky. I can write the cube root of x to the 4th as x to the 4/3. 4 goes in the top, 3 goes in the bottom. So I can write that radical as a fraction exponent. If I had the 4th root, say I had a 4th root of 5y to the 3rd, I can write that as 5y, in parentheses, to the 3/4 power. This exponent goes on the top, this root goes in the bottom. So if I have a fraction exponent, I can write that as a radical, or a square or cube root, or a 4th root, or whatever it may be. So, I'm going to have you type some things in your calculator. I'm going to have you practice typing some things in your calculator. So if you have one of these calculators, these are the commands that you'll use. If you're using Desmos, or if you're using some other calculator, the commands will be slightly different. But in our calculators, most of you know how to type in a square root. You push this second button, and then you push this x squared button that has the little radical symbol above it. To type in a cube root, if you push the math button, the 4th option down, so if you push math and then you push 4, the 4th option down is the cube root button. So if you push that button, type in whatever number you're curious with, it will tell you what the cube root of that number is. So I want you to experiment with this here. So I want you to try this out in your calculator. Give yourself a couple minutes. If you need to pause this video, you can. But remembering that in order to do the cube root, you push that math button, or if you're in Desmos, there's a cube root button. To type in an exponent, remember to click that little arrow key that's pointing up, the exponent button that's above the divide sign. So first of all, I want you to type in, just to check, I want you to type in the square root of 2. So the second square root button of 2, and then 2 to the 1/2. So remember to type a fraction in your calculator. If you do 2 and then the exponent, and then in parentheses, 1 divided by 2, that'll give you 2 to the 1/2. I want you to type both of those in your calculator, see what you get. Same I want you to do with these, the cube root of 2 and 2 to the power of 1/3. I want you to tell me what those equal. I'm going to get out my handy dandy calculator, and we're going to check some of these. So when I type in the square root of 2 in my calculator, I get 1.414. There it is. I pulled up Desmos so you can see Desmos if that's what you're using at home. The square root of 2 is 1.414. Well, let's try 2 to the power of 1/2. 1.414. Coincidence? Let's try 2 to the cube root of 2. So the cube root of 2 is 1.2599. 2 to the power of 1/3 is 1.2599. The next one I had there was the square root of 10. The square root of 10 is 3.16. What do you think 10 to the power of 1/2 is going to be? 3.16. What about the cube root of 222? I think was the last number I had there, 6.055. What about 222 to the power of 1/3? 6.055. That's crazy. That's crazy. All of these going from radical form to this form with a fraction exponent, they're exactly the same way. It's two different ways of writing the exact same thing. Okay, so as a class, let's take a look at this. So if I have x to the a over b power, that's going to be the same as a radical or a root, where the bottom goes in the root and the top goes in the exponent. So this is the same as the b root of x to the power of a. 3x to the 4/5, that's going to be the same as the fifth root, because the bottom becomes the root. The fifth root of 3x to the 4th. The fifth root of 3x to the 4th. If I go backwards, this is the square root of x to the 4th, so I'm going to write a little 2 here so I don't forget it's a square root. If I'm going to write this as a fraction exponent, the 2 is going to go in the bottom, the 4 is going to go in the top. Well, x to the 4 over 2 power is the same as x squared. 4 over 2 is x squared. Some of you might have already known that just from looking at the square root of x to the 4th is x squared. 2x to the 4 over 2 power is going to be the square root, because the bottom of this fraction goes in the root, of 2x to the 4th power. Okay? So that's what we're doing here. We're converting between exponent and radical form. We're converting between exponent and radical form and vice versa. Let's do a couple more. So x to the 4/5 power, that's going to be the fifth root of x to the 4th. The fifth root of x to the 4th, the bottom becomes the root, the top becomes the exponent. The seventh root of x to the 1st power is going to be x to the power of 1 over 7. The root goes in the bottom, the power goes in the top. 5x to the 4/5 is going to be the fifth root of 5x to the 4th power. The root goes in the bottom, the power goes in the top. The cube root of x to the 5th is the same as x to the 5/3. The root goes in the bottom, the power goes in the top. Okay? So that's what we're doing. That's what we're doing in this assignment, in this lesson, is we're just changing forms between exponent form and radical form. Because sometimes you'll notice if I'm given something in like this form, it might be easier to simplify or easier to deal with in a radical form, or vice versa. So sometimes it can be handy to change between the two. So I'll leave those up here that you can kind of do by yourself, that you can review. You can pause this video and work on those. But that's it. Hopefully by the end of this lesson you now feel comfortable switching back and forth between radical form and exponent form. And as we've reviewed, I hope you feel comfortable simplifying radicals using prime factorization. So that's all I've got for you today. I really hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever. And I hope that you enjoyed that as much as I did.